everyone, welcome back to Digits. Today we're going to be discussing proportional relationships and reminding ourselves what those are and actually putting those on a graph like we did yesterday. So let's go ahead and get started on 12-2. A proportional relationship can be represented by equivalent ratios. So we talked about what equivalent ratios were, and those were ratios that were written would actually mean the same thing. Like, say, we're going to go back to Miss Kevin's favorite food, obviously, pizza. If you have a pizza that has 8 slices, and you've eaten 4 of those 8 slices, that's the same as eating 1/2 of the pizza. Okay? So, the ratios 1/2 and 4/8 are equivalent. The ratios 1/2 and 4/8 form a proportional relationship. So I want you to copy down this and the little diagram and put that into your notebook before we start working out the problems. Alright, pause the video if you need a second to copy it down, and then push play when you think you've got everything. Work this problem in your notebook. Label each pair of ratios with yes or no. Now guys, when you see something like this, it says label yes or no, you gotta prove how you know. Y'all gotta stop just writing answers or circling random answers. This is math. You have to prove it. Okay, you have to know Miss Kennedy doesn't believe anything you say. Alright? So, what you have to do is look at your first fraction of your set. Okay, we're going to start with 2/8. We have to figure out if 2/8 and 3/12 are equivalent, or if they're proportional. The first thing you need to do is look at your fraction and decide, yes or no, can or can it not be reduced? So you have to see if you can find a common factor of 2 and 8. And guys, that's going to be 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So your first fraction is equivalent to 1/4. Now what you have to figure out is 1/4 equivalent to 3/12. So I'm going to put my pen back on black. I don't really know why it was on red. So let's figure it out. Okay? Well, when you're trying to find a proportional relationship, you've got to figure out did you do the same thing to your numerator as you do to your denominator? Well, let's look at the numerator. Between 1 and 3, you have to multiply by 3 to get 3. Now let's look at the denominator. If you multiply by 3 on the numerator, you have to multiply by 3 on the denominator. Is 4 times 3 12? Yes. So that's how you know this is a proportional relationship. You could also do it like this. Since we reduced our first fraction, we can also reduce our second fraction. 3 and 12. Find a common factor of 3 and 12. And if you're looking at that, you can see that 3 can go onto itself and 12. 3 divided by 3 is 1. 12 divided by 3, well, that's not 3. It's 4, excuse me. 1/4 is equivalent to 1/4. So A, yes, that is equivalent. Now let's move on to B. We'll do this one again together. Look at your first fraction. We have 1/3. We need to reduce it. Let's look at it. Can 1/3 be reduced? Well, you can see that 1 can go into 1 and into 3, but 3 divided by 1 is still going to be 3. So it's going to stay 1/3. Okay, let's look at our second fraction. Can 3/9 be reduced? Yes, by 3. So 1/3 is equivalent to 3/9. Okay, so we have another yes. look at C. We have 6/15 and 9/18. Let's look at our first fraction. Can 6/15 be reduced? Well, if you're not sure, let's look at 6. What are some factors of 6? 3 and 2. 15. Some factors of 15. 3 and 5. Narrow your couple. So 6 and 15 can both be reduced by 3. 6 divided by 3 gives us 2. 15 divided by 3 gives us 5. So our 6/15 gets reduced to 2/5. Now let's look at 9/18. Can 9 and 18 be reduced? Yes, 9 can go into itself and into 18. So 9 is going to turn into a 1. 18 is going to turn into a 2. Is 2/5 the same as 1/2? And before you say yes or no, think about it this way. If you and your brother had to share something, like a snack, and he gives you 2 out of the 5 pieces of that snack, that half. Oh boy, I hope you know it's not half, because if you think it's half, your brother's ripping you off. It is not equivalent. So, C is no. Actually, X. No. Alright, so let's make a bet on D. If you think the answer is going to be yes, I want you to go up to the board, to the front of the room. Make sure you let Miss Carpenter or whoever know what you're doing. If it is yes, I want you to write yes on the board. If it is no, I want you to write no on the board. Don't tell anybody what you're doing, so that way people who are not watching the video, that way they don't know to do this, and you get brownie points because you actually did it. And it's kind of fun, and some people have no idea what's going on. So, let's do that. If you think it's yes, write yes on the board. If you think it's no, write no on the board. Make sure you write it on the whiteboard, not the community board. Okay? Alright, let's look. 5 and 20 to 6/24. So, look at your first fraction. 5/20. Can that be reduced? Yes. 5 can go into itself 1 time, and into 20 4 times. Alright, let's move over. Can 6/24 be reduced? Yes. 6 can be reduced by, oops, go back. Oh my gosh, go back. There's your answer. So 6 can be reduced by itself, which gives you 1, and 24 can be reduced by 6, which gives you 4. So if you put yes on the board, you are correct. And in case you weren't sure, here's the answers. In case you doubted me, here are the correct answers. Alright, let's keep going. I want you to solve this one by yourself. Oops, excuse me. Which pairs of ratios have a proportional relationship? Alright, so I want you to solve this by yourself. And when you think you got it, push play and check your work. Okay? Pause the video, don't cheat, so you can figure it out by yourself. Alright, so here is the answer. 4/3 and 16/12. 4/3 is simplest form. So yes, the first one is proportional relationship. 2/3 and 4/9. 2/3 is 2/3. 4/9 divided by oh sorry, I gotta focus. 2/3. Oops, oh my gosh. I've lost my train of thought. Sorry, 2 times 2 is 4. 3 times 2 is not 9, so 2 is not equivalent. Let's look at the third one. 2 times 2 is 4. 3 times 2 is 6. So, number 1 and number 3 are proportional relationships. Oh, So smart. So good. You got this right. Give yourself a big pat on the back. You deserve it. All right. I want you to copy this into your notebook. A proportional relationship can be shown using tables, graphs, and equations. In case you're not sure, table, graph, equation. Okay? So I want you to copy all these three methods down into your notebook. Here's how you would read that table. You have an X group and you have a Y group. So for how many X's you have a specific number of Y's. What we have is 2 X's to 1 Y. So our ratio is 2 to 1. Okay? Or, sorry, 1 to 2. You write it backwards when we're talking about X and Y's. Okay? So for every 2 X's, you have 1 Y. Alright? You do the same thing again. For every 2 X's, 1 Y. Again, 2 X's, 1 Y. 2 more, 1 Y. Okay? They work the same every single time. The equation of the line is Y equals 1/2 of X. Is that true? Is 1 1/2 of 2? Is 2 1/2 of 4? Is 3 1/2 of 6? Is 4 1/2 of 8? Yes, they're all 1/2. Okay? Copy all this down to your notebook, please. Alright, this is going to be like an addition to go to your graph. Just copy this down because you already have the graph copied down. You just got to copy down the rest of the notes. A graph shows all of the points with a proportional relationship if it is a straight line that passes through the origin. Yesterday we had Arthur tell us the simplest form of this. If it forms a straight line going across your, going across your axis, or across your plane, whatever you want to call it, then that means they're proportional. Now, if your lines are doing this, and you have dots all over the place, and they don't join a line, then you know it's not proportional. Okay? Just in case you're wondering how that works. Alright, so what you have to do, and actually we're going this one together, we have to figure out if these two relationships are proportional or not. Okay? So let's look at our first couple of numbers. This means for every X amount of numbers, we have a certain Y amount. So 3 9ths. Can that be reduced? Yes, it can. That can be reduced to 1/3. Okay? So let's look. 1 times 4 is 4. Is 3 times 4 12? Yep, it is. Alright, let's keep going. 1 times 6 is 6. 3 times 6? Yep, 18. You have to also know your multiplication tables for this stuff, guys. It makes it a little easier. So if you're a little rusty, you might want to practice a little bit more. 1 times 12 is 12. 3 times 12 is 36. So right now, it looks like this first one is a proportional relationship. So let's put a check by it, and then we'll check after a minute, okay? Alright, I want you to check the second one by yourself and see if you can get if it is a proportional relationship or not. Okay? Can you erase this little check? And let's move on. Oh, we got to hurry. Alright, so here's how to check the first one. They went ahead and plotted 3 9ths, 4 12ths, 6 18ths, and 12 36s. And you can draw a straight line all the way through between that straight. So that's how you know that, yes, that is a proportional relationship. Ding! 1 is correct. Let's move on. Oops. Here's the answer for number 2. You can form, boom, a straight line. Boom. So yes, it's correct. Go ahead and get on to your digits assignment for today. Good job on your notes. Have a wonderful afternoon and a great new year. Bye.